ladies and gentlemen. I wanted to take the opportunity being here to talk to you about cybersecurity vertical organization in Fujitsu, and at the same time serve as the introduction to our next guest speaker. Most of you are not probably aware that Fujitsu is in the top 5 ranking of cybersecurity service providers worldwide, with thousands of dedicated security professionals in the world and more than 400 based in Europe and Middle East area. Apart from that, I would like to mention that we have 5 global security operations centers worldwide, based in Japan, the UK, Singapore, Australia, and the US. So we are able to provide managed security services to customers in a 24/7 model and following the incident management around the sun. Apart from that, we have, as you can see in the screen, we have our global threat map that we build ourselves with what we call in security honeypots. Honeypots are basically servers that we have exposed to the internet, and they are located in Fujitsu data centers and at the same time in public cloud infrastructures like Google, like Amazon or Microsoft sites. So the way it works is that we expose the servers and we have sensors, and we let the hackers and the malicious actors in the internet to take control on these servers, and we analyze the tools they use, we analyze their behavior, and we analyze how they make use of our machines, so that we can learn the new techniques that they use to protect the assets of our customers. So as you have seen in my colleague Ravi's presentation before, security is one of the top pillars in the internet and digital society, composed by a huge ecosystem of devices connected to the internet, devices that are emerging from traditional PCs, laptops, to every kind of mobile devices, to cars, televisions, medical instruments, and a huge range of elements. So you can imagine that all these infrastructures and endpoints have a processor power that malicious actors can make use of it to cause harm in infrastructure from customers or even critical infrastructures for countries, like electrical plants or nuclear plants or different big infrastructures. From our experience of more than 40 years in the cybersecurity space, dealing with customers, we have identified 2 major points, 2 major topics that the customers, that matters to our customers. The first one is the context, and the second one is the intelligence. About the context, as I mentioned before, we have 5 global security operations centers, but what we are trying to do is to design hybrid models where we make use and leverage the global capabilities that we have, and at the same time, we try to locate and we try to be local, understanding local context and local language from the customer. So these hybrid models have a global layer and a local layer, and that's why we are investing also in resources in the Middle East, and we are able to speak the security language locally. About the intelligence, this is, I think, the most important topic and also very innovative in terms of cybersecurity. Fujitsu is investing in developing artificial intelligence and machine learning techniques around cybersecurity in order to be able to collect and digest a huge quantity of information coming from internal and external sources, coming from internal firewalls and security devices, and external sources like, for example, social media or even the dark web. So with artificial intelligence techniques, what we do is to analyze internal and external behavior, and with a piece of software on top, we are able to automate and orchestrate the response to these malicious behaviors that we can detect with our technologies and our sensors. So, as I mentioned, Fujitsu is investing together with an ecosystem of partners, and one of these partners is here today with us, Symantec. Let me please welcome our next speaker, Mr. Darren Thompson. He is the Vice President and Chief Technology Officer for Symantec in EMEA.
Well, good afternoon, everybody. It's a great pleasure to be with you in one of my favorite cities in the world. My name's Darren Thompson. I'm the Chief Technology Officer for Symantec. It's my job to work with our customers, engage strategically with our customers and with partners like Fujitsu to solve some of our customers' most strategic problems in the security and privacy space. For those of you that are not very familiar with Symantec, we are the largest dedicated security software company on the planet. We have about 3,000 engineers who are writing software, many of which, the components of which you'll be using. I'm going to talk to you, though, about a group of only 100 or so engineers that exist at Symantec that we call the Symantec Research Labs. These are the Symantec employees who are thinking about the next 3 to 5 years in terms of innovation in security. And I want to do a couple of things in the next 30 minutes with you that I hope will really change the way you frame and think about security and privacy in your own organizations. I think it's fair to say, given all of the innovation that's going on right now in some of the spaces that have already been mentioned on the stage today, that if we don't think very radically about how we handle security and privacy, we are not going to keep up with the innovations such as the ones that you've already seen on the stage today. I think my industry, the security industry, is guilty of what I regard as incremental innovation. We are incrementally innovating. We are gradually making security better and better. But my personal feeling is that given the pace of change, given this race to digitization that you've already heard about today, in every single vertical market, we've got to think very, very differently about how we do security in our businesses. And software companies like Symantec are on the leading edge of research and development around some of these new innovative ideas. The engineer in me, I regard as a could-we person. I'm constantly asking myself, could we execute in the following way? Could I attach my car to the internet? Could that car perhaps be driverless? Could I innovate in some way in my particular business in order to get to market quicker, to maximize revenue, to maximize efficiency? Could I digitize in some way to get that done? Most of the people in the IT industry, and certainly the security industry, are built that way. We are educated to be could-we people. My suggestion is that in the security field, we need to start populating this industry with a few more should-we people. I've been party over the last 3 years to some very, very innovative IoT projects, for example, some of which we'll talk about in just a second. And it's very interesting to me that in the very early design meetings, in the very early project meetings in some of those projects, the table around me is surrounded by could-we people. We're obsessing over how could we digitize our businesses. What could we achieve in terms of revenue or growth or something else by use of digitization, by use of this IoT framework? I see very few people around that project table who are asking a different kind of question. a should we question. Is what we're talking about actually the right thing to do? And if it is the right thing to do, are we thinking the right way about it? Do we have all the information that we need to understand the unintended consequences of what we're about to do here? Now, the law of unintended consequences, for those of you that are not familiar with this is not an IT science topic. This is actually a sociology topic. It's a topic of social science. And the IT industry is not full of these people. It's not full of people that are educated in concepts like unintended consequences. Let me just give you a quick snapshot of what this means. In the law of unintended consequences, we first of all talk about manifest functions. Manifest functions are the things that we're all obsessed with. These are the reasons that we write project plans. They are the goals that we would like to achieve to move ourselves or our business forward. In IT, we are excellent at this. We are trained, and our DNA is absolutely tuned to some of these latent functions. I set myself a goal, I write a project plan, I move towards my goal. Ultimately, I probably achieve the goal. What we're not so good at in my industry and in the IT industry at large are what we call the latent functions. These are the things that we did not plan, we did not foresee. And what's interesting about this is in IT science, there is almost no definition of a best practice to start to think about these things. There is a best practice, though. It comes from social science. And so the first thing that I want you to think about in your own businesses, and certainly for the IT industry in general, is do we have enough people in the decision-making processes to ask these sorts of questions? Let me indicate to you now why I think this is important. I mentioned I'm lucky enough as a CTO to be involved in some pretty interesting IoT projects around the world. I want to share with you now some of the intended and unintended consequences of some of those projects. You'll be aware of some of these. This is Google's driverless car. Google actually have an office right next to Symantec in Silicon Valley. I regularly now see this vehicle going round and round the block on Ellis Street and the adjoining streets around our office. I've nearly been run over by the thing a couple of times. Glad to report it's more intelligent than I am, so it typically stops before it hits me. Now, what is the intended consequence of the driverless vehicle? I find this very inspiring. The intended consequence of the automated vehicle is something in the region of a 94% reduction in human fatalities on the roads. If we suddenly transported ourselves to a world where all of our vehicles were automated, there is an estimation of a 94% reduction in road fatality. That's a pretty inspiring intended consequence. You can absolutely see why car manufacturers and others are obsessing over this piece of innovation. Very, very exciting. Again, the technologist in me, the engineer in me, is incredibly excited about the potential here. And by the way, this is real. I see these things every other month. Let's think about unintended consequences. This is a quick screenshot from a white paper that I was involved in writing a few years ago now. Symantec partnered with some of the larger car manufacturers around the world. What you're seeing on the screen here were the ingress points and the egress points of one of the first automated vehicles that we researched. Everything you see in red is a vulnerability. Everything you see in red is a potential risk and threat to the driver of that vehicle and potentially to the manufacturers and partners involved in building that vehicle. This was an example, and this is a few years ago now, this is an example of a very excited project team obsessed with the intended consequence, but not considering enough some of the unintended consequences of this design. The second thing I want to leave you with is you need security and privacy experts around the table in the very first design meetings that you're involved in your companies. I'm very happy to report that the car manufacturing industry, specifically the manufacturers that Symantec are dealing with, are absolutely getting their head around this problem now. Somebody made a very interesting statement to me a few weeks ago in one of these manufacturers, which was, Darren, we don't know very much about the revenue opportunity and the market opportunity for automated vehicles. But we know one thing. The best-selling automated vehicle will not necessarily be the fastest. It won't necessarily look the coolest. It won't necessarily have the nicest color, but it will be the most secure. Now think about that for a second. The best-selling vehicle will be the most secure. You're witnessing a revolution in the way business, in all vertical markets, not just cars, think about security. Security and privacy as a competitive differentiator. If you build an unsecure vehicle, people are not going to buy it. People are not going to buy it. Let's talk about another unintended consequence. Some of you would have seen some news around internet-connected pacemakers. Intended consequence, my doctors and medical professionals can constantly monitor my health. They can constantly monitor my physiology. I can get a pre-warning as to something that's up. Something's bad. I should go to a hospital. We can take proactive measures to keep me alive, to keep me healthy. Unintended consequence. Once again, the design team, very excited about the intended consequence, moving so fast to market to roll this thing out to save lives, they did not consider the security and privacy implications of an internet-connected pacemaker. So as I mentioned, all of this action that's occurring, this race to digitization across vertical markets, is making us at Symantec think very, very differently about how we innovate in the future. We think security fundamentally needs to change. How does it need to change? Well, you've heard words like artificial intelligence, deep learning, machine learning. You've heard some of those phrases already today. But what does that actually mean? What does that mean in security? What could that turn into? How might that benefit you as individuals and you as businesses? Let's talk a little bit about that. What could we become in security by use of these techniques, by thinking outside the box, by thinking very, very differently about how we go about our jobs as security professionals? I want to start the next section of the presentation by introducing you to a game. Quick show of hands. Anybody come across this game before? Fold it. A couple of people. Okay. I can tell that you're the people because you're looking at your phones right now. This is an incredibly addictive game, and before I introduce you to it, I want to warn you of a potential denial of weekend attack. If you start playing this game, you won't stop. I'm warning you right now. What is Fold It? Well, Fold It is an incredibly addictive, very compelling game that you can play on your phone or on your laptop. It's actually, I think of it, I'm quite old, so I remember the days of Tetris. It's a very, very complicated version of Tetris. It's basically what it is. We're solving three-dimensional problems. We're scoring points by solving those problems. Now, of course, this game is being run by millions of people around the world. They're thoroughly enjoyed and addicted to this game. What they don't know, most of them at least, most of the people that play this game are not aware that by solving some of these problems, they're actually solving real scientific issues. What the users of this game are actually doing is something called protein folding. I'm not clever enough to understand what that is, but it's a segment of biology which is incredibly important in things like the cure of HIV, for example, finding a cure for Ebola, some of these big research topics. What's happening here is that every problem that's solved in this game is capturing data. That data is being correlated, and the correlation of that data is going to a big data engine. Artificial intelligence and machine learning are applied to that data, and as a result, these gamers are solving real-world scientific problems. These are peer-reviewed medical papers and journals that are exposing some of the benefits of this research. So what are we seeing here? We're seeing non-experts en masse solve massive problems. None of these people are biologists. Most of them don't even know they're solving the problems. But those non-expert users en masse with an application of machine learning and artificial intelligence and analytics are solving big issues. At Symantec, we think that has a lot to do with what security needs to look like. And I want to talk you through now some of the research projects that we're involved with in this area. As a security professional, I engage with businesses at an executive level to help them define risk management strategies and security strategies. And it is a fact right now that I witness in those businesses something that I call the diseconomy of scale in business. What does that mean? Every time we add an employee to our business, we add risk. Every new employee is an extra attack surface, as we refer to this in security. In fact, they're more than one attack surface. The person themselves is something that can be manipulated. The devices they carry, and there will be more than one, of course, are all potential attack surfaces for the cyber criminal. I call this 1 + 1 = 1.5. For every employee we add, we don't get the full benefit because we see them as a risk. Now, in the UK, I'm not sure this is the case in Dubai, in the UK we have something in society that we call neighbourhood watch. Neighbourhood watch is simply neighbours on the street banding together and helping each other out, protecting each other, keeping an eye on the street, making sure that the street is kept safe. Now, what's interesting about neighbourhood watch, of course, is that demonstrates exactly the opposite to the way we think about people in security. The more people in my neighbourhood watch project, the safer we are. The more eyes are on the problem. Well, what if we could apply that principle in security? Using big data and analytics, the power of the crowd, and non-expert users, people that are not security professionals, we think can actually help us to solve some of the biggest challenges in security. Let me give you an example as to how that might work. This is based on a real research project that we're carrying out at Symantec right now. What if, under certain circumstances, based on a threat landscape and the data that Symantec is gathering around a customer, what if we could send alerts to people? This might be a mobile phone alert, could be a pop-up on a screen. There's lots of ways that we could deliver this, that ask a very, very simple question. Like this one. It seems that you're sending earnings information about our company before its release date. Is that you or isn't it? You don't need to be a security expert to answer that question. Are you sending this data or aren't you sending this data? Yes or no? Now imagine if we could apply this at scale to our entire employee base. The telemetry that comes out the back of those answers could be very, very interesting to security experts. It could pre-alert us to something bad that's happening on our network. In this case, some kind of data breach, some kind of exfiltration of confidential information. I'll give you another quick example here. What if we asked the question, it seems that you're encrypting your backup. Yes or no? Well, if you don't know what an encrypted backup is, the answer is no, right? But let me tell you something about encrypted backups. When we see encrypted backups on a customer's network at scale, that is a surefire sign that they're under a ransomware attack. Some of the advanced ransomware code that we see will deliberately encrypt backups. Guess why? Because once I encrypt the laptop or the device, I don't want that user going to their backups to retrieve their good data. So I'll go and encrypt the backups first. We could get ahead of a ransomware attack by 10,000 users telling us, no, it's not me encrypting backups, that's somebody else. Non-expert users helping the security strategy. What does that do to something like incident response? Well, I think potentially what it does in something like incident response is it makes the incident something different to today. If I think about something like the WEMEI virus, which we all saw on a global basis a year or so ago, 2 years ago now, the WEMEI was a botnet virus. This was taking ownership of IoT devices, in the case of WEMEI, fridges, CCTV cameras, things like that. The cyber criminal, they went out, they took these devices hostage, and they used the power of these devices, turned them against us, used their processing power to actually take some of the largest SaaS providers on the planet down. Well, maybe in the future, the mere possibility of an attack like that could be seen. I call this left of bang. If we have a timeline in security, the bang might be the breach. And we're entirely obsessed with right of bang right now. Something bad happens, we react, we improve things, we mitigate, and we start again. What if we could have a crystal ball? What if we could get left of bang, and we could predetermine something like the WEMEI botnet virus actually happening? How might we do that? Well, some other research that we're involved in involves IoT security. What you're seeing on the screen here is something akin to the nutrition label that you might see on some food, on a breakfast cereal or something like that. What if all of the IoT devices that we attach to the internet had something similar? A very, very small footprint, a very, very simple device whereby we can capture some of the typical characteristics of that device. A fridge, a CCTV camera, a dog's collar, whatever it might be. We could capture things like how much energy should this device consume? How does this device typically interact with other devices? What data should this device be taking or giving? If we were to do that, again, at scale, in the same way that I talked about with employees in a company, we can start to do things like this. We can use the back-end analytics to create baseline behavior. How would a CCTV camera typically interact with the world around it? In the case of Mirai, if we'd have had something like this in place for all of those, there was something like 500,000 CCTV cameras involved in that botnet attack. If we had this in place for those CCTV cameras, we would have been able to see a difference in behavior at scale across all of those, frankly, dumb devices. We didn't do anything particularly clever on the device, just like we didn't particularly train our users in the previous example. But the devices at scale, implementing the power of the crowd, can tell us interesting things about the internet. Let's go through some other examples here of actual projects that are going on at Symantec at the moment. Here's an issue, and here's why we think we need to think radically about security. You're going to hear again and again, the user is the weakest link. The employee is the weakest link in security. If only we could just stop our people doing stupid things, we'd all be out of trouble. Rubbish. Rubbish. My industry has done a terrible job at educating people. More than that, we've been deluding ourselves that we can even educate them. My mother, when she's on Amazon shopping, buying me lovely presents, really doesn't care about security very much. Her task, her ambition, is to get to Amazon as quickly as possible, do the shopping, get on with the rest of her day. Trying to educate my mother in the world of phishing attacks and email and websites and drive-by attacks and watering holes and all the things that, as a security professional, I'm into, we're on a lost cause. We're not going to go anywhere with that. So at Symantec, we're thinking very, very differently about how we empower our users. We're at a point in history right now where we're more reliant on individual users' decisions than we've ever been in security. We're relying on non-expert users to make really good decisions with zero training, zero knowledge, and almost zero interest. So what can we do about that? How might we think radically about the way that we interact with our users? Well, we think a lot at Symantec about the user interface. If you take this simple URL here, I just made this URL up, by the way. Don't go there. I don't know what's there. But what does this URL tell a non-expert user? Well, it tells us something about gold. It also indicates I might win some as well. There's really no psychological response here that would expect this user to make a good decision or a bad decision. There's nothing there at all. If I showed you this street, this is a street from close to where I live in the UK, nice, quaint English country village in the sunshine. If I asked you to walk down that street, how would you feel about that? You feel good about that? You feel okay about that? You feel pretty safe in making that decision? What about this street? How do you feel about that? Slightly differently, probably. You might be okay. You might be braver than me. You probably feel differently about those two streets. What I just did by showing you those two pictures is I prompted 1 million psychological triggers and responses based on the visual stimuli that I just put in front of you. In psychology, we talk a lot about psychological triggers, psychological acceptability. The human being has evolved over 200,000 years to make these kind of decisions based on these sorts of sensory inputs. In IT, the best we can come up with is this. Now, you're getting a couple of psychological triggers here. You're seeing green and red. There's something embedded in us that thinks red's bad and green's good. Other than that, we're doing a pretty poor job, I would suggest, at indicating to you, number one, what this means, in case you care, and number two, what the good decision is. So when my mother sees this before she gets to Amazon, likelihood is she's just going to click whatever it takes to get to Amazon and do her shopping. This is the root cause problem in user education. We need to stop educating our users to become experts, and we need to start thinking about the psychology behind the decisions that those users are making. We need to trigger emotional responses to enable people to make better decisions. Some really interesting research that we're doing in our research labs around the user interface. In software, when we build user interfaces, we try to make them as beautiful as possible. Good example of that would be what Apple do with their iPhones and their iPads. Beautiful user interfaces, intuitive and easy to use. I heard once that Apple designed their user interface with a 5-year-old brain in mind, just to make sure that whoever gets this device can intuitively use that device. Beautiful interfaces. What if we were to dynamically change the look of that interface based on risk? We've mentioned the value of data, of machine learning, of artificial intelligence. What if all of that data can tell me something about my business's threat landscape, and based on the threat landscape that surrounds a user, we can change their user interface to make them feel differently. Maybe then they would make a different decision. Now, we're researching this at the moment. This is applied research in the early stages. But we're thinking about things like colors, tones, darkness, light, size of text, size of window. There are things that we think we can do to trigger emotional responses to help our users make better decisions for security. I want to talk to you a little bit about incident response and what we call security operations centers. For those of you that have security operations centers, you'll know that we have a problem right now. There are so many potential security incidents that there aren't enough security analysts, human beings on the planet, to deal with them all. And we have so many security tools that are all trying to do their job, generating log files and data, that we're completely overwhelmed by the amount of data. At Symantec, we often see an advanced, sophisticated attack on a business get through and reach its objectives, not because we didn't capture it in one of our security tools, but because all of the other security tools were masking the problem. There were so many log files, our analysts could not see the wood for the trees. So about 4 years ago, we started to apply machine learning, in this case, supervised machine learning. This is human beings telling the machine learning algorithm about what's good and what's bad. What that did is it allowed us, you can see on the middle chart here, to start to get much better at prioritization. There was still human interaction involved here. The analyst needed to tell the machine what was good and what was bad, but over the time, the machine learning algorithm would learn what's good and what's bad and start prioritizing incidents better so that human beings could focus on the things that really mattered. In the last couple of years, we've taken this even further, and what we're really excited about here is correlated machine learning. This is taking out, to a certain extent, the involvement of the human being and creating algorithms that say, well, C on its own, this thing on its own, that doesn't look like something bad. But every time I've seen that, in conjunction to these two other things, A and B, it has been bad. So whenever I see A and B, I should suspect C of being bad. This is correlated advanced machine learning. At Symantec, we have one of the largest faculties of machine learning PhDs and experts on the planet. What has that meant in real terms? As a security professional, I get very, very frustrated when I hear presentations like this one talking about machine learning and artificial intelligence and how exciting it all is without the prize. What does it mean? Well, I'll tell you what this means. We have doubled the amount of resolved high-severity incidents in our own customers and in our own networks in the past 12 months. We've doubled them. We are solving more high-risk incidents now than we ever have, and we've doubled them in 12 months with the application of this technology. That's machine learning and artificial intelligence working in the real world, solving real problems. I want to end on this one here. I mentioned earlier the concept of left of bang. I guess the holy grail for me in security strategy would be that the incident is the mere possibility of a vulnerability. The incident is no longer the breach. The incident has something to do with the energy that's being manifested and that could cause a breach. We used the example earlier of the WEMEI botnet virus. What if we could have detected that 6 months before it happened because of what was going on those IoT devices? Well, at Symantec, we're also thinking about the vast global intelligence that we have to help customers to predict the future, to predict the risks that are likely to happen to their business, based on who they are, their vertical markets, their size, their politics, their geographic location, their revenues, a million attributes, not least of which the threat landscape that surrounds them. Based on all of that correlated and applied machine learning, what is likely to hit you soon? Which devices in your organization are at most risk based on a global threat intelligence? Which users, based on their behaviors in your organization, are likely to get targeted with a phishing attack? Predicting the future. This is the holy grail. This is the utopian view of security. And we're moving rapidly towards a world where this becomes a possibility. So I want to leave you now with a few sort of key takeaways here. First of which, think about what I said at the beginning of this presentation. You're not all security people, but whatever business you're in, you're innovating. You're pushing that digitization forward. You want to enable your businesses and value your businesses differently based on this push to digitization. Think about the unintended consequences. And if you don't feel capable of thinking about those consequences, bring somebody into the decision-making process that is capable of that. I'll give you a very quick example of that really working. I'm a CTO. I spent 25 years in this industry as a technologist. I was a programmer 25 years ago. My background is technology. Symantec have just spent money and invested on me to attain a degree in psychology. What a ridiculous thing to do. Why would you train your CTO to be a psychologist? Well, hopefully, given what I've just told you, I don't need to answer that question for you. There's an example of a business thinking differently about its skills. Social science and IT science need to come together. They are very separate disciplines. They're taught in different faculties in the university. We're doing a lot of work at Symantec to influence the curriculum in IT science in the education sector to bring more social science into that skills base. Security and privacy need to be present on the very first design meeting. Whether you're designing a car or some sort of IoT device, please bring security experts into the early discussions. It will save you a lot of pain down the road. IT users, the non-experts in your businesses, could become part of the solution to the problem that we're describing here. Let's stop trying to make them security experts. My mother is never going to be a security expert. Nothing wrong with some awareness training, but let's think about how we can help those users to make good decisions. And then lastly, in your own businesses, what could you do with analytics? I used the example of the game, the Fold It game earlier. I've given you some examples as to how we're thinking about analytics in security. We think it's nothing short of a revolution. Think about what that revolution could mean to your business, but while you're thinking about that, please be aware of the unintended consequence. Thank you very much.